Hello everyone. Wanted to go over the proper way to measure a guitar pickup and show you how you can be fooled by different readings that are coming out of a multimeter. Now here I have the meter that I use to measure my pickups. It's a DE5000. This will do both resistance, inductance, and capacitance. So I want to show you the difference between those and how you can be fooled by them. So the first and most obvious one is resistance. Everyone sees resistance on pickup manufacturer websites, and a lot of people think you can use that to determine the output of the pickup. But one thing that you can be fooled by is going here, and if I bring something more metallic near it, that just jumped up there to 6.8, and that's down to 6.3. So an external interference can cause that to change. So I have two pickups here that are ones that I have wound. This one called Freeport, and this one I've called Shady Cove. So let me show you the resistance measurements here. First, I will do Shady Cove. Here's the wire in that. So that measures 10.34. All right, get that out of the way. Let me get the Freeport one here and do the measurement on it. And that measures 8.7K. So most people would think that this one here, the Shady Cove, is going to be the higher output, when in reality, it's this one. So let me show you one of the other measurements right quick. So now I have the meter set to inductance, and this is series inductance. You can tell by the LS here, measuring at 100 Hertz. So the Freeport here is 4.6. The Shady Cove one here is 4.3. The reason for this is that there's a relationship between the number of turns of wire and the inductance. The reason why you're seeing the difference in the resistance reading is the Shady Cove uses 43 gauge wire, which is thinner, and therefore has a higher resistance per foot versus the 42 gauge used on the Freeport here. Now, another thing about DC resistance is that it's actually temperature dependent. So right now we have this pickup, which is measuring just over 3 henries of inductance. And then on the resistance here, is measuring just over 7. So what I'm going to do is I'm going to use this heat gun here and heat this pickup up. Now, I won't make you listen to it because that can be annoying, but then I will show you the results. Okay, so that's only been about 2 minutes at max, and you can see we've gone up to 7.6. So that would be a different pickup in a manufacturer's line. But if we go here to inductance, it's still at 3, just over 3. All right, so the last measurement for a pickup is the capacitance of the pickup. Now, one of the reasons why you need a special meter like this is so you can vary the frequency on it that it's measuring at. So right now it's set to 100 Hertz. We're getting up over 1,000 nanofarad here, but we can adjust the frequency here and see now we are measuring in picofarads and go up here to 100 kilohertz, which is the standard for measuring capacitance and pickups. So we have 148 picofarads, which is vastly different than this 100 Hertz. Now, a lot of meters that you can buy, like this one here, measures at 100 Hertz. So you're not actually getting the true measurement you need to see exactly the capacitance of the pickup. All right, so let's get the 3 measurements on this vintage late 60s Fender pickup that someone's put a different lead on here. And then I'll show you what you can do with that. So we have the inductance. Then on capacitance, we need to change it to that 100 kilohertz. And then we just need the DC resistance. All right, so let me swap over to the computer and I will show you guys how to use this information to figure out how this pickup will sound. All right, so in a program called LT Spice, I have this schematic put together where this is a AC input, and then these three right here symbolize the measurements we took from the pickup. This is the inductance, the resistance, and the capacitance. These down here simulate about a 30-foot guitar chord. And then this trace is coming out of this point here. So this is as if you were to take that pickup, hook it straight to a chord, no volume, no tone controls, and then see its frequency response here. So we can see on the low end, pretty flat, but right in around say 7 to 800 hertz, it's starting to boost it, and it peaks right here at 4.07 kilohertz. And then right in and around here, it's a 5 to 6 kilohertz. It's starting to cut the frequencies. So this is how you can use those measurements to simulate the frequency response of a pickup.